All right, this is Math 208, Week 4, Section 4.1, Solving a System of Equations Graphically or Numerically. All right, so the directions say the graphs of the two equations are shown right here. One of them is y equals 2, so it's flat. The other one is x plus y equals 1, and it's a diagonal. And it says use the intersection to identify the solution. Okay, so what does that mean? The solution means we need to identify, the solution is where do those two lines intersect, where those lines intersect. And so we're going to zoom in, and we can see that those two lines intersect right here. And so that means the solution in this case is, let's do it in red, is -1, 2. And why is that the solution? Because that's the intersection between the two lines, and it's located at -1, 2. Now, how do we know that that's the intersection? The solution. Another way we could do it is to plug in, so we've got that point, and we say that the solution is -1, 2. And what we're going to do is we're going to take the two lines, y equals 2, and the other line, which is x plus y equals 1. And what we're going to do is we need to make sure that this ordered pair works for both lines. Well, start with -1, 2 for this one. Is there an x value? No. Since there is no x value, it means we don't even need to worry about this value. And we're going to replace the y with a 2, because wherever you see a y, you're supposed to replace it with that value. So we end up getting 2 is equal to 2. And is that a true story? Yep, that's a true story. So that's a smiley face, so to speak. So now that that one's a smiley face, we need to make sure that -1, 2 works for this line. So wherever we see an x, we're going to replace with a -1. And wherever we see a y, we're going to replace with a 2. And -1 plus 2 is equal to 1, which is exactly what we were hoping it would equal. So it's a smiley face on both of them. So that's proof that -1, 2 is a solution. -1, 2 is a solution for both lines. Same kind of problem, only this time we don't have to prove it. We've got our two lines here. The blue one is x plus y is equal to 1. The pink one, purple one, whatever, violet, is x plus 2y is equal to -2. And the idea is, remember, the solution is where those two lines intersect. And we can see it intersects down here. So I'm going to zoom in, and we want to see, okay, where is that point? And that point is, well, that's 3, 4, 5, 6. Okay, so that's 4 right there. And then right here is, of course, -3, because it said so. So that intersection right there is 4, -3. And that is your solution for this system of equations. So this time we want to use the table. We're being told to use the table. Now, we could graph these two lines right here, and if we were to graph those two lines, I don't know what it would look like. Let's kind of figure it out. So if we were to graph it, there's our graph. And if we were to graph this one, the way it would look, because you got to remember the quick way to graph, y is equal to -x plus 16. And why did I do it that way? Why did I rewrite it? Well, because remember, y is equal to mx plus b. So the fast way to graph an equation is to first identify the y-intercept. Where does it cross that y-axis? And then use the slope to to, add the extra points. Does it go up? Does it go down? And in this case, the slope is down 1 over 1, down 1 over 1. Because when it's just a negative x, that really means it's a negative 1x. And so that's negative 1 is really can be thought of as negative 1 over 1. So negative 1 can be thought of as negative 1 over 1. So that means your rise and your run. So you're going to go down 1 over 1, down 1 over 1, down 1 over 1. All right, so the idea would be, if we're going to go back here, and this line right here is going to start way up at 16, and then it's going to go down 1 over 1, down 1 over 1. It's going to look something like that. I'm estimating. Now this line right here, y is equal to 3x, it does not have an intercept, so it's going to start right here at the 0, at the origin, and it's going to go up 3 over 1, up 3 over 1, up 3 over 1. So it's going to look something like this-ish. And we want to figure out that that intersection right there. So what does that mean? That means, I'm going to zoom in, that means that these two lines at that location right there, they have the same x value and they have the same y value. They have the same x value and the same y value. So I explain all that because what that means is if we have the table, all we need to do is figure out where do we have the same, well, they're always going to have the same x value. Where are they going to have the same y value? And you see it right here. When x is 4, the y on both lines is 12. So that intersection over here, right here, is 4, 12, and that is your solution for this system. So in this problem, they specifically want us to create a table for each of these equations and then identify where in that table these two equations give us the same value. So the idea is we're going to start with, let's see if I can zoom in here. I'm going to zoom in. And where this is 0, that's saying take the x, replace it with a 0, and then y equals 0 plus 3, so that is 3. Then we're going to do that right here, 1. We're going to replace the x with 1, so that becomes 1 plus 3, which is 4. And then we've got 2 plus 3, which is 5. And then we've got 3 plus 3, which is 6. So I inserted the x into the equation and wrote the answers. Now we're going to do the same thing with the next line. We're going to replace the x with a 0. So 9 minus 0, and let's do it in red, is 9. 9 minus 0 is 9. Now we've got 1, so 9 minus 1 is 8. And then we've got 9 minus 2 is 7. And then 9 minus 3 is 6. And so now can we identify the solution? Yes, we can, because we could see in the table that both equations equal 6 when x is equal to 3. So what does that mean the solution is? The solution is when x is 3, y is 6. And that's where these two lines intersect. So what does that mean? That means if we were going to graph these two lines, they would intersect at 3, 6. They would intersect, I'm just assuming, I'm just kind of pretending. They would intersect right there at 3, 6. We don't really know what the lines would look like. We would have to do it, but perhaps the black line would look like, I don't know, this. That's that first row. And the second row, I can see that the numbers are falling, so maybe they're going like this, and then so there you go. There's our two lines if we were to graph them, and we know that they would intersect right there at 3, 6. So here we are being told specifically to graph these two equations over here, and that's going to show us the solution. Remember, that's the intersection of those two lines. So remember in, I think it was last week, we learned a really cool shortcut for graphing equations. And it requires us to get the equation into y equals mx plus b format. All right, so it's got to be in y is equal to mx plus b format. That's super duper important. So this guy is not quite in mx plus b format. There's your b, and the b is supposed to be in the back. So this really, if we were going to write it in slope-intercept format, would be negative x plus 6. So that means the intercept is 6, and the slope is down 1 over 1, down 1 over 1, down 1 over 1. And then this one, I'll do in blue, is already in slope-intercept format, so we don't need to do anything with it. That means it's going to start at negative 4, and then here it's going to go up 1 over 1, up 1 over 1, up 1 over 1. All right? So those are our two lines, and we're going to quickly graph those, and they're really easy to graph. So that first one, 6, starts at 6, so I'm going to put a dot at 6, and then it's going to go, there's my dot, and then it's going to go down 1 over 1, down 1 over 1, down 1 over 1, and that means it's going to look like this. Oops, I lost my pen there. It's going to go down, 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 down. So that's what it's going to look like, right? Now we got to do the blue one. Now the blue one, y is equal to x minus 4. So it's going to start at negative 4. So it's going to start down here at negative 4. And then the slope is up 1 over 1, up 1 over 1, up 1 over 1. So let me zoom in a little bit. And it's going to go up 1 over 1, up 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And there is your blue line, and you can totally see where they intersect. They intersect right there at 5, because that's the x coordinate, and the y coordinate is 1. 5, 1 is where they intersect. And so the solution is 5, 1. Now we know that. We're done. But they want us to also show that the solution is 5, 1 by using a table, numerically. So they've already given us values of x to plug into our equations. And so let's do it. So we've got 3, so we're going to replace the x with 3. So 6 minus 3 is 3, and then 6 minus 4 is 2, then 6 minus 5 is 1, 0, negative 1, because you should see the pattern. It's going down by 1 every time. Now we're going to do this one, and this one we'll do in blue. So it's going to be 3 minus 4 is negative 1. And then it's going to be 4 minus 4 is 0. And then it's going to be 5 minus 4, which is 1. And you should see that it's getting bigger by 1 each time. So there's our 2. There's our 3. And there we go. And so where are the y values the same? They're the same right here at 5, 1. So our solution is 5, 1. Now we know that for two different ways. One, we see it on the table. but we also see it over here in the graph because the two lines crash at 5, 1. So this one has like 21 sections, 21 parts to this question. So I'm just going to consolidate it into just two basic parts. One, we're going to solve this system of equations using the graph, and then we're going to solve it again using the table to verify that our answer is correct. So remember, the shortcut when we're going to graph, we want to do y is equal to mx plus b. So this first line right here, there is no b. So it's going to start at the 0, and it's going to go up 2 over 1, up 2 over 1. So I'll do that one in black. And it starts at the origin, and it goes up 2 over 1, up 2 over 1, up 2 over 1. And that is our line. So that's the one that I'll do in black. And then we want to do this one. And now this one, the intercept is 4, so it's going to start at 4, and the slope is up 1 over 1, up 1 over 1. So it's going to start at 4 and then go up 1 over 1, up 1 over 1. So where am I going to do that? Oh, so it's going to start at 4, and it's going to go up 1 over 1, up 1 over 1. So let's do that, and let's do it in blue. So it's going to start at 4, and then it's going to go up 1 over 1, 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 and there. Is that it? I don't know if I can. So what I need to do is, because, see, this is why we're going to learn a new technique, because drawing, you got to be really precise. And check this out. Check where I kind of screwed up. Let's look at the black one. The slope is up 2 over 1, and then here, up 2 over 1. So the next black really should have been here. And we can see that the blues also are there. So really, if we wanted to, we should be able to. We should see that the blue line is going like this, and really the intercept should have been right here. My drawing was not perfect enough. My drawing, the black should have been going like this. And the drawing isn't perfect enough. And so that's why we can see that the solution right there, the intersection of those two lines is 4, 8. How did I get that? Here's 4 and 8, 4 and 8. So the two lines really cross at 4, 8. Now eventually, we're going to learn how to get this answer using pure algebra, so we don't have to rely on trying to draw pictures perfectly. So now that we know the solution is 4, 8, we need to do what they say, which is now we got to prove it using a table. And so what we're going to do is we can say, well, one of our equations is y is equal to 2x. The other equation is y is equal to x plus 4. And really, let's just do 3, 4, 5, and be done with it. Because really, if you think about it, we already know the answer, don't we? We already know that 4, I don't want 3 to go there. Yikes! Geez, what did I just do? There we go. Okay, I don't want 3 and 4 and 5 to go there. So what I want is I need to erase the 3 and the 4 and the 5, because what I want is I want the 3, the 4, and the 5 to go right here. 3, 4, 5. All right, so now what that means is we're going to replace 3. We're going to replace the x with the 3. So that's going to be 2 times 3. That gives us 6. Then it's going to be 2 times 4. That gives us 8. Then it's 2 times 5. That gives us 10. Now we're going to do it in blue. and we're going to use this equation down here. So that's going to be 3 plus 4 is 7, and then it's going to be 4 plus 4, which is 8, and then it's going to be 5 plus 4, which is 9, and there we go. We can now see that right here our y's match, so that's proof that 4, 8 is indeed the solution to that system of equations. All right, so we're going to use graphing in order to find where these two lines intersect to solve. And we want to find that solution. All right, so what we're going to do is we're going to take these two lines and we want to write them both in slope-intercept form. So we've got x plus y equals 1. And then down here we have negative x plus y equals negative 1. So I just rewrote these problems over here, these equations, because what I want to get this guy into, each of them, is I want to get them into that y is equal to mx plus b format, which means this x is on the wrong side because I want to get the x on the right side. So I'm going to subtract by x, and I'm going to end up with y is equal to negative x plus 1. So that's the first line. And then this line, this x is on the wrong side, so I need to add both sides by x. And so that gives me y is equal to x minus 1. So we have these two lines, all right? And we need to graph these two lines over here on our coordinate grid and using the shortcut. So let's start with this one. It says start at 1, and then your slope is down 1 over 1, down 1 over 1. So start at 1, and then we're going to go start at 1, start at 1, and then go down 1 over 1, down 1 over 1, down 1. Now I learned my lesson from that last video. I'm just going to keep it going. And I'm not going to worry about trying to estimate what it looks like. I'm just going to fill in all those stinking dots. All right, there is that first line. Now we're going to do the same thing with the second line. Now this line says start at negative 1 and go up 1 over 1, up 1 over 1. So we're going to do that in blue. It says start at negative 1, which is right here. Then it's going to go up 1 over 1, up 1 over 1, up 1 over 1. And already we can see where these two lines intersect. They intersect right there. And that location is 1, 0. So that is your answer for this line, this solution. The solution is they intersect at 1, 0. Another example where we are supposed to solve by graphing. And so when we solve by graphing, we need to first write both of those lines into slope-intercept form. So that's 4x plus y is equal to 0. And all I'm doing is rewriting these equations over here. And then the next one is 6x plus y is equal to 4. And remember, the slope-intercept format is y equals mx plus b. So that means we need to get the x on the right side of the equal sign. So we're going to subtract by 4x. And so we end up with y is equal to negative 4x. So that is the first line. There is no intercept. Now we're going to take care of this one as well. We've got to get rid of that negative 6x from the left side. And so we end up with y is equal to negative 6x plus 4. So here are our two lines that we're going to be graphing over here on our grid. All right, so the first line starts at 0 because there is no intercept, and then it goes down 4 over 1, down 4 over 1. So let's do that. Starts at 0, and then it goes down 4 over 1, down 4 over 1. There is our line. Now I'm going to backtrack a little bit, and because I have no idea what this answer is or where this answer should be. So there is our first equation right there. Now that second one, way over here, right here, it's going to start at 4, and then it's going to go down 6 over 1, down 6 over 1. So it starts at 4, right here, and it's going to go down 6 over 1. So down 6 over 1 puts it here, and then down 6, 1, 2, 3, 4, 5, 6, and over 1 puts it right here. And there, we can see it right there. That is our intersection. That's where the two lines cross. So if I wanted to, I could draw this line. But the important thing is that we recognize that the intersection is right there. Right there. And where is that? Well, that is at 2, negative 8. So our intersection is at 2, negative 8. I'm going to zoom out, and that, whoa, gee whiz, get back here. And that is our solution for this. Now you're starting to see, man, drawing these pictures is a little cumbersome, and it also requires us to draw precisely. And so in future videos, we're going to show you how to solve these equations using algebra without having to draw these pictures. We're going to solve by graphing, and we're going to begin by writing both lines in slope-intercept format. The first one already is, it's y is equal to 4x. He's already in slope-intercept format, but this guy is not, the second one. So let's do that one. That's 4x plus y equals 8. And we're going to subtract the 4x from both sides. That gives us y is equal to negative 4x plus 8. So here are our two lines that we're going to graph. So this first one starts at 0, and then the slope is up 4 over 1, up 4 over 1. So let's do that. It starts at 0, right here, and then it goes up 4 over 1, up 4 over 1, and I might need to backtrack, so let's do that. So then it goes down 4, backwards 1, down 4, backwards 1. So that is our line, that first line. And then let's take a look at this line right here. So this says start at 8, and then your slope is negative 4, which means down 4 over 1, down 4 over 1. So we're going to start at 8. Let's do it in blue. Start at 8. We're going to go down 4 over 1, and there's our intercept. Down 4 over 1, our intersection, I mean. And there's our line, and we can see that the intersection, the solution to this system of equations, is right there at 1, comma 4, because there's the 1 and there's the 4. 1, 4 is our solution for this system of equations. All right, this one is exactly the same. We're just going to solve by graphing. What makes this one a little on the tricky side, but not much, is the fact that we're going to involve fractions. It's going to involve some fractions. So let's start by writing both of our equations, and we need to convert them into that slope-intercept format. So here are our equations. This is not in slope-intercept format, so I've got to subtract by 4x. And so I end up with y is equal to negative 4x minus 8. That's pretty quick and easy. Here's where we're going to get into fractions, Clearly, this is not in slope-intercept format, so you need to subtract by x, and you're going to end up with 2y is equal to negative x minus 2. The thing about slope-intercept format is that y needs to be all by itself, and here's a 2. And they're connected by multiplication, so the way you get rid of it is by dividing everything by 2. Here's where our fraction comes in. So that first part is y. Now this is negative 1 divided by 2, so we're just going to leave it as negative 1 divided by 2, as negative a half x, because that's the x. Then this says negative 2 divided by 2, so that's negative 1. So there are our two lines up here and here. So let's do this one first in black. Negative 8 is our starting point, and then the slope is down 4 over 4, down 4 over 4. Oh my goodness. Negative 8 is our starting point, and then because it's down 4, wait, what was it? Down 4? Yeah, down 4 over 1. But we can't go down 4 in our graph because we're already kind of at the bottom. So we're going to go backwards. Instead of going down 4 over 1, we're going to go backwards. And so we're going to go backwards 1, up 4. Backwards 1, up 4. Backwards 1, up 4. Backwards 1, up 4. So there is our first line in black. And then our second our second line starts at negative 1, and then the slope is negative 1/2, meaning it's going to go down 1 over 2, down 1 over 2. So it's going to start at negative 1, right there, and then it's going to go down 1 over 2, down 1 over 2, down 1 over 2. And it looks like we're going to have to do some backtracking, so let's do that. So then we're going to go backwards 2 and up 1, and there is our intersection. We can see that, okay, so the line is going like this, but the intersection is right there. And that intersection, and our intersection is, and I didn't draw it very perfectly, but it's at negative 2, 0. It went backwards 2 and didn't go up and down at all. So it's negative 2, 0. And that is our solution to this system of equations.